Hi, I'm Donald O'Donnell MacDonald, Old MacDonald Sr.
And I'm Al. And we're the most casual sports network ever to exist. Tonight, as this crisis unfolds, here first, we have exclusive interviews with the one and only
Touchdown Tommy.
Tommy Brady, the quarterback of the New England Patriots, who we also have.
Bill Belichick.
Yes, that's the coach. And
And
Marshawn Lynch.
Marshawn Lynch.
Yes. He is a quarterback. Running back, no. Quarterback.
Nope, no, you got it right the second time.
Okay. Same thing, it's just a ball.
Yeah.
Yeah.
Sports.
Yeah, we overanalyze all the time. Yeah.
That's what we do
So
here.
he's coming in, and we're gonna see what their views are on Deflategate. Hey guys, Al here, and you hearing it here first. This is Bill Belichick that we're gonna interview, seeing who is responsible for deflating these balls. Bill.
Let me take a look at my playbook.
You don't need to do that.
I take my playbook everywhere.
Okay. So again, who do you think is to blame for these deflated balls?
Well, Al, I don't really know what you're talking about. I believe that we won that game fair and square. We really pulled it out at the end there.
The balls are deflated and they're easier to catch. Do you think Tom Brady did this?
Al, did you listen to me when I talked? I
No,
told you that
I didn't know.
we didn't do it. We played our hearts out in that game, and it really showed. All the practice that we've been putting on the field really showed on the field that day.
Well, let's see what Tom Brady says.
Hello, all. This is Old Donald here, and today we have a very special interview with the one and only TD Tommy.
Yeah, that's right. I'm Tom Brady.
Tom Brady.
Tom Brady.
Now, Tom Brady, there has been a lot of speculation about what the Twitter followers are calling hashtag Deflategate. What is your stance?
Didn't do it. Have nothing to do with it. None of my players. I don't know what to say, but I take no responsibility for this. They were not deflated, and I threw some good touchdown passes.
Okay, Tom Brady. We took the air pressure of the balls that were used in the first half of the game.
Prove it.
We took the air pressure, so we are proving it. They were deflated. So how do you feel about that?
Bad, I think. I'm not really sure what my emotions are right now. I'm gonna go away. Thank you.
Wait, Tom Brady.
No, bye-bye.
I have one more question.
What's your question, world?
How does it feel to marry someone who makes more money than you?
You know what? Scandalous.
You heard it here, folks. Tom Brady. Scandalous. This is Donald O'Donnell MacDonald, Old MacDonald Sr. here, reporting with the very special Marshawn Lynch. Today, we're going to be talking about the very scandal that is hashtag Deflategate. Marshawn, what are your views on this scandalous topic?
I'm only here because I don't want to get fined.
Okay, Marshawn, you say that, but why don't you tell us how you really feel?
To be honest, I mean, what can we do? Balls getting deflated sounds like a huge issue to you, but in reality, is it? It's all about the game, and it's all about Marshawn Lynch. What can Marshawn Lynch do to carry his team to victory? All right, all these ball issues can be put aside and focus on the real issue at hand. And the headline tomorrow saying Marshawn Lynch carries his team to victory.
Okay, Marshawn. Now you believe that you carry your team. What do you think of Tom Brady? Do you think that he did it?
Who?
Touchdown Tommy.
Who's that?
He's the quarterback for the Patriots. He's won like 3 Super Bowls.
Never heard of him.
You heard it here, folks. Marshawn Lynch carrying the team.
Hello, all. We're back. And we have with us a very special certified nerd. Yeah, nerd, that's how you say it. And he's specializing in the area of physics, so we can settle this debate of were the balls, did they have any effect even if they were not deflated? Just say if they were. Did they have any effect on the players catching them? Andrew Olaford, give us a rundown.
Hello. Well, they did.
Okay.
When we did tests, the balls bounced. Like my fellow nerds tested.
I get it.
We found the balls bounced with more pressure.
Okay.
So when we dropped them from a higher height, they dropped. They went faster,
Okay.
and then they bounced higher.
Do you have any data to back your hypothesis up?
Yes, I do.
Okay.
Some videos included.
Okay, let's explore.
How does the air pressure of the football affect the change in momentum in the collision between the football and the receiver's hands? This was measured by dropping a football and recording the height of the bounce in contrast to the varying air pressures we tested. We then calculated the velocity of the ball before and after using the slow-mo gizmo called Logger Pro to prove that the less PSI in the ball there is, the larger the momentum transferred to the receiver's hands. This makes it easier to catch as the ball does not have as elastic of a collision and it is a softer catch. This was the case in the New England Patriots deflate gate in the AFC Championship. This graph shows our first trial in the 2.2 psi football. It shows the data and the maximum height, which is 0.638 meters high. From Logger Pro, we then got more data, which we'll include later in the video. This is our second graph, which shows the height and all the information of the tests of the 6.5 psi football. This is the third graph, which shows the information for the 10.7 psi football. Here are our calculations showing all the data and all the information about the trials. We use the energy equations MGH1, which would be the first height, initial height, to find the initial potential energy, minus MGH2, which is the second potential energy, equals the amount of energy lost in the collision. In trial 1, it ended up that there were 3.75 kilojoules lost. In the second trial, there was 1.88 kilojoules lost. And in the third trial, there were 2.0 kilojoules lost. These trials go from 2.2 psi to 6.5 psi to 10.7 psi. Then, from that, we found the initial velocities, which we found using the energy equation mgh equals 1/2 mv squared, which is potential energy equals kinetic energy. To do this, we then simplified the equation to set it equal to v, to make it the square root of 2 times g times h, where the masses cancel out, equal the velocity. Using this, we found out that right before impact, before the bounce, each time, the ball was going 5.72 meters per second. And after, in the first trial, it was going 3.74 meters per second, 4.83 in the second, and 4.77 meters per second in the third trial, right after the impact. Then using this data and the momentum equations, this is the initial data, by the way, we did m1 v1 equals m1 times the second velocity plus the change in momentum. Using this, we found that the change in momentum was 0.79 kilogram meters per second for the first, 0.36 for the second, and 0.38 for the third. Some sources of error in this could have been the spin of the ball as it hit. After it hit, it generally started spinning when it bounced off. Some other sources of error are the fact that with our camera, we can only measure up to 1/420th of a second, which means that we can't use more than 3 significant figures. And when we're using Logger Pro, we could only go to about the centimeter when we were using our data points, which means we couldn't go past the 100th, past the 3 significant figures there either. Which means, although our data is accurate to the point that we've written, it could be much more accurate with better information. Also, some of the accuracy and plausibility of the data. With this shown, we use both Logger Pro and calculations to find the velocity, and they were actually very close, within 10% error in every case. This means that this experiment does show accurate data, and the data shows that from the first trial of 2.2 psi to the second trial of 6.5 psi, there was a great increase in the change in the there was a very small change. Sorry, there's a big change in the energy lost. So in the first trial, there was a lot of energy lost because the ball was not as inflated. But in the second trial and third trial, there was a very significantly smaller amount of energy lost. And between the second and third, there was very little change to no change. This proves our hypothesis.
Up next, Al and I cover circular motion.
Circular! Woo! Horses.